Hello everyone, I am Zibran Zarif. I'm recording this video as a short presentation on what I have done to complete my assessment task. First of all, I want to thank you so much for giving me the opportunity to present my work. So without further ado, let's jump right into the problem statement. So my task was to develop a machine learning model that can detect potential AI use by comparing candidate coding answers to responses generated by AI models like GPT-4, 4 Turbo, and 3.5 Turbo. For this problem, I was already given a dataset and I had to complete these sets of tasks from data understanding, model development, model evaluation, and documentation. So I'll give you a quick overview of what I have done. So this is my source code. If you see inside the source code, there are multiple directories. I'll start with the data directory. This directory contains the dataset that I was provided with the task. Then we have the deployment directory. This directory has all the files relevant to deployment. I was actually able to complete the optional deployment task as well, so I decided to provide the deployment source code as well. The following directory has all the files relevant to my large language model implementation. Then we have the models directory itself that will contain all the fine-tuned models. This directory has all the Jupyter notebooks. This directory has all the Python scripts. These are some helper files. And finally, we have the requirements.txt for quick installation and the readme.md file, which basically presents a detailed documentation of the project. I would recommend using any markdown viewer to view this readme file. For example, if I do Ctrl-Shift-V, I can simply see the rendered version of this readme file. So now let me give you a quick walkthrough of what I have done so far. Starting with the problem statement. So I basically had to develop a machine learning model that can predict similarity score given a candidate answer and an equivalent AI generated answer. And the predicted score, it actually is a floating point number ranging from 0, which means not AI detected, to 1, which means a lot of AI detected. Since the prediction is actually a continuous value, this is a regression problem which can be solved in multiple ways. In this problem's context and within the given time frame, I was able to implement two different solutions which I will demonstrate now. So the first solution was fine-tuning multiple sentence transformers on the given dataset, and then deploying the best performing fine-tuned model to HuggingFace and then integrating its API with a custom Flask web application. I will quickly show you the final result of my first solution. At first, I will go to HuggingFace. As you can see, this is the interface of the deployed model on HuggingFace powered by Gradio. I have already pasted a sample question and a candidate answer with its equivalent AI generated answer. Now if I click submit, you can see it predicts 33% similarity. I have also deployed the final fine-tuned model as a Flask web application, which looks like this. Again, I have already pasted the contents. So this will be the coding question. This is the candidate answer and the AI response. Now it would simply use this HuggingFace API to generate the similarity score. So now if I click on Analyze, you can see it gives me that the candidate's code is 35.48% AI generated, which is cool. Now let me go back to my documentation. So what I showed was the first solution to the problem. I also implemented a second solution utilizing OpenAI's GPT-4 large language model to predict similarity score. So let me start with the first solution, which is fine-tuning sentence transformers. Now, as the first task asked me to understand the data before proceeding, I have actually documented all the details about the dataset. So the original dataset is located into this directory. This directory actually has one directory inside with another file. Within this particular directory, we have 63 subdirectories, starting from source code 000 all the way to source code 062. Now each of these subdirectories have some more files, 8 files to be specific. Now each of these subdirectories, they actually represent a coding question and its respective answers completed by both candidate and AI. A particular subdirectory, say this one, has these files. So for example, the JSON file, it actually has the coding question along with certain metadata. Then this particular file, the source code 000.jav, has the Java implementation of this coding question, because this coding question actually required the answer to be provided in Java. And all of the other files are basically equivalent AI generated codes. These 6 files actually represent 2 different samples of 3 different variants of LLM. So 2 AI answers for GPT 3.5 Turbo, 2 for GPT-4, and 2 more for GPT-4 Turbo. This particular directory also has an Excel file. Let's see what's inside this file. So if I close this directory and go back to this file, you see there are only 3 columns in this Excel file. This file simply maps each of the candidate source code with its equivalent AI generated codes, and it also assigns a plagiarism score. If you look closely, each of the candidates coding answer is actually associated with 6 different samples of AI generated answer. Since, as mentioned before, the original dataset, it actually has 6 different variants of AI generated answer for each candidate's answer, and this column represents nothing but the plagiarism score. For example, if I pick a particular row randomly, for example this one, it means that the candidate's answer to the 9th coding question is 10% similar to the coding answer generated by GPT-4 Turbo. And this 01, it means it is for the second sample to that answer completed by GPT-4 Turbo. So now that we understand the dataset, we have to pre-process the dataset. So let's go back to the README file. The data pre-processing step does nothing but converts this original dataset into this format. You see, for model training purpose, we need to have a consistent format of the data. We also need to convert the entire dataset into a single data frame. As you can see, this particular data frame is quite easy to understand. You can clearly see each question, its candidate answer, and its equivalent AI answer associated with a similarity score. The detailed documentation of pre-processing can be found in the corresponding Jupyter notebook, or you can also check the equivalent pre-processing script file. The final data will be saved as preprocessed data.csv. Now, how to perform this particular preprocessing? To perform any of the operations, you can either use the Jupyter notebooks from this directory, or you can also use the Python scripts from this directory. As you can see, these are the exact same files with exact same operations. However, I personally prefer Jupyter notebooks since it allows for detailed documentation. So if I simply run all of the cells together, it would simply generate a new file, which is the preprocessed data.csv. The preprocessing involves quite a few steps which I have documented in this Jupyter notebook. For example, it uses a load question data to load all of these subdirectories and its contents. It also uses two more functions. For example, this preprocessed data function is the core method that creates this particular data frame. So if you see what this function does is basically for each of the coding question, and then for each of the AI models, and for each of the two samples, it simply creates a new row with the coding question, with the candidate answer, and the AI answer for that sample of that GPT model. And it also keeps into account the similarity score, which it simply finds from this labeling file. Now that we are done with pre-processing, we can simply explore the data. So this is what the first 5 rows look like. This is the last 5 rows. This is a generic information of the data frame. These are some more information. This is important. This is where we check if there are any null values, and there are not, which is good. Now we can simply move on to the training phase. Let us go back to the README file. As you can see, the model training here, I actually fine-tuned 5 different sentence transformers on the pre-processed dataset. The model training involves several steps. The first is splitting the dataset into train and validation data. The second step is quite important, which is feature extraction. If you have noticed, in the pre-processing step, we created 2 more columns. These columns are simply where we merge the question with the answer. So for example, this means I have merged this column and this column. And this column simply represents the merged output of this column and this column. So these 2 columns are simply the features to my model, and the label will be nothing but the similarity score. During model training, these are considered as features, and they are actually encoded into numerical vectors or embeddings. These embeddings actually represent the features extracted from the text data. Then I simply instantiate a sentence transformer model. That is when the core feature extraction happens. The feature extraction simply converts these features to embeddings, which are nothing but vector representations of the text that capture semantic meaning, making them suitable for tasks like what we are doing, which is similarity measurement. I also define a loss function as cosine similarity loss. The entire goal of the training model is to minimize the cosine distance between embeddings of semantically similar texts and maximize the distance for texts that are not similar. I also define an evaluator and about how the features are encoded. These features are simply passed through the sentence transformer model, and this model, it simply tokenizes the text and then converts it to dense embedding vector. Now if I jump back to the training source code, in this notebook all you have to adjust is the model. I have trained 5 different models, but for this demonstration purpose I'll only show this particular model since it's quicker. You also have to define certain hyperparameters. I defined 5 and 16 for this demonstration. Then if I run the model, it would simply train the model right here. As you can see, this particular model will be saved into this particular directory, which is the models directory. So I'll wait for the training to complete. Let us go back to the README file. After the model is trained, we actually evaluate the model. And we evaluated the model on 8 different metrics. So during training process, all I did was I used this same exact training notebook and I simply changed this model names, and that is what generated the output models. As you can see, the fine-tuned model is saved right here, and then when I was done, all I had to do is move on to the evaluation file and run this file to generate the model evaluation. As you can see, it generated all of the relevant metrics, which I then documented in my README file. The summary of this documentation is written here. For all of the different metrics, it seems like the fine-tuned version of all distill Roberta, it consistently performs best in terms of error metrics and also in terms of variance explained, which is R squared. These two models also perform significantly well. The mini-LM models, however, they are relatively weaker. So after model evaluation, all we have to do is check it with inference. So let's go to the inference notebook. If I run this notebook, you can see for these unseen data, it predicts the similarity score, which is 74%. When we are done with evaluation and inference, and we have decided which model we want to develop from the evaluation metric, it's time for model deployment. Since this particular model performed better overall, I decided to export this model and compress it for deployment. So I'll go to the export file. I'll run this file, making sure the correct model is selected. Now if I run the notebook, you can see it generated two different files. This one is the exported file and this one is the quantized file. Now this is the final model that we are going to deploy. For this short video presentation, I demonstrated the entire training pipeline with the mini-LM model since it is quicker. However, when I did the project on my own, I actually exported and quantized this particular model since it performed the best. And this was the model. The quantized version of this model was what I actually deployed to HuggingFace. Now as for the deployment into HuggingFace and Flask, I have already shown its demo. So let us go back to the README file. Here I explain about the model compression, how I quantized it. I provided images to HuggingFace model. I also provided snapshots of the Flask web application. Then I also implemented a second solution with large language model, which you will find in this particular directory. As you can see, there are 3 files. As the name suggests, these files actually contain, for example, this file contains the candidate's answer, this is the question, and this is the AI answer. And the large language model technique does nothing but clever prompt engineering with LangChain to invoke OpenAI to generate a similarity score, which is clearly documented in the README file. And finally comes the installation. I have put together all the commands and processes I followed to replicate my project, and I have tried all these steps into multiple devices without any issue. However, if you do run into any issue, you can simply reach out to me via my email. I would love to help you out. And about installation, I must say that you have two options here. You can either use the Jupyter notebooks as I have demonstrated. However, you can also use these scripts to perform the exact same tasks. You have to simply copy these commands and specify the models and hyperparameters to simply replicate what I have done. As for conclusion and future works, due to time constraints, I couldn't experiment further. For example, I could only deploy one model since it was relatively the best performing. However, in future, I will also try deploying the other performing models which were fairly good candidates. And I also wanted to employ advanced techniques such as Similarity Predictor, which simply utilizes the similarity score along with the candidate's answer and finds out a pattern. And from that pattern, it can directly predict a similarity score from the candidate's answer without any reference or guidance of equivalent AI answers. And also for my second solution, I used OpenAI's GPT-4. However, in future, I would also experiment it with open source options like Llama or Mistral, etc. Finally, there are some helper files in this utils directory if you're wondering. Other than that, I would conclude my presentation, and I want to thank you again for your patience, and I'm really grateful for having this opportunity. Thank you. We'll eagerly wait for your valuable feedback.